Welcome you all for the next session of concrete technology, that is chemical action on the concrete. When we are dealing with the durability of a concrete, chemical attack which results in a volume change, cracking of a concrete and the consequent deterioration of a concrete becomes an important part of discussion. In the previous video, we studied the durability of a concrete and what are the factors which influences the durability of a concrete. Even some of the chemical actions will also affect the durability of a concrete. So what are those chemical actions which will affect the durability of a concrete? That we'll see in the upcoming videos. So the first chemical action is sulfate attack. So what is the sulfate attack and how it occurs in a concrete, and what are the preventive measures can be taken to prevent the sulfate attack on the concrete, that we are going to study in today's video lecture. Okay, the most of our soils contain some sulfate in the form of calcium, sodium, potassium and the magnesium. They occur in a soil and groundwater. Okay, the sulfates are present in a soil in the form of calcium, sodium, potassium and magnesium. They occur in a soil or a groundwater. Because of solubility of a calcium sulfate is low, groundwater contain more of other sulfate and less of calcium sulfate. Ammonium sulfate is frequently present in agricultural soil and water from the use of fertilizers or from the sewage or industrial effluents. Decay of organic matter in the marshy land, shallow lakes often leads to the formation of hydrogen sulfide gas, that is H2S, which can be transferred into sulfuric acid by bacterial action. So the water used in a concrete cooling towers can also be a potential source of sulfate attack on concrete. Therefore, the sulfate attack is a common occurrence in a natural or industrial situations. So the water which is producing from all these area, if you are using in a concrete mixing, then this will cause a sulfate attack to the concrete. Or concrete cooling towers, the water which is released from a concrete cooling towers, also then a potential source of sulfate attack on concrete. The solid sulfates do not attack the concrete severely, but when the chemicals are in a solution, they find entry into a porous concrete. For example, the water containing the sulfates, okay, that is in a liquid condition. When this water penetrates into the concrete and react with the hydrated cement products, then the chemical attack will occur. Not the solid sulfate will not attack to the cement. All of the sulfates, magnesium sulfate causes the maximum damage to the concrete. Characteristics with whitish appearance is an indication of sulfate attack. You can see any of the concrete structure which is showing the whitish appearance, then you can recognize that this is from the sulfate attack. The concrete structure, anything which is showing the whitish appearance on the surface, then we can say it is a sulfate attack. The term sulfate attack denotes an increase in the volume of cement paste in a concrete or the mortar due to the chemical action between products of hydration of cement and the solution containing sulfates. When the solution containing sulfates enter into the concrete, it increases the volume. In the hardened concrete, the calcium aluminate hydrate can react with the sulfate salt from the outside. The product of reaction is a calcium sulfoaluminate, forming with the framework of a hydrated cement paste. Because of increase in volume of the solid phase, which can go up to the 227%, a gradual disintegration of concrete cracks will take place. So how this sulfate will react with the concrete? They have given equations. The first equation is calcium hydroxide containing cement. This is a calcium hydroxide which is present in a cement. When reacts with the ammonium sulfate, that is Na2SO4 dot H2O, it will give the calcium sulfate 0.2 H2O and 2 NaOH plus H2O. Okay, and next reaction is with the calcium aluminate hydrate. For example, 3CaAl2O3 0.12 H2O, when reacts with the ammonium sulfates, it forms 3CaO.Al2O3 0.3CaSO4, that is calcium sulfoaluminate known as etriganite, which contains a sulfate content which causes the whitish appearance on the surface. On the other hand, the magnesium sulfate has a more far-reaching action on the other sulfates because it reacts only with the calcium hydroxide and hydrated calcium aluminates like other sulfates, but also decomposes the hydrated calcium silicates completely and makes it a friable mass. Hence, the ammonium silicate or the sodium silicates, which will react with the concrete more and forms the some calcium aluminosulfate, and which causes the cracks in a concrete and volume change in a concrete. The rate of sulfate attack increases with the increase in the strength of a solution. The sulfate content is more in the solution, then the sulfate attack will be more. A higher saturated solution of magnesium sulfate can cause a serious damage to the concrete with a higher water cement ratio in a short time. If you are using more higher cement ratio and more the water containing magnesium sulfate, then the water containing magnesium sulfate will cause the more sulfate attack. However, if the concrete is made with a low water content ratio, the concrete can withstand the action of magnesium sulfate for 2 to 3 years. The concentration of sulfates is expressed as the number of parts weight of SO3 per million parts, that is ppm. So this is how the sulfate attack will cause from magnesium sulfate, sodium sulfates and aluminosilicates, sulfates which are present in the water and the soil. So, but how to prevent? These sulfate attack is causing the volume change and the cracks and damage to the building. So, we have to prevent for the durability of a concrete. So, these are some of the methods of controlling the sulfate attack. That is, first one is use of sulfate resisting cement, quality concrete, use of air entraining reagents, use of pozzolanic materials, high pressure steam curing, and use of high alumina cement. Okay, so we'll study how this will prevent the sulfate attack. As we studied in the first chapter, the types of cement, there is one type of cement which is called as a sulfate resisting cement. So what is this sulfate resisting cement? The most efficient method of resisting sulfate attack is to use of low C3A content. The cement which contains less alumina content, then it is called as the sulfate resisting cement. In the first chapter we studied the C3A content less than 7% will give a rough division between the cement of a good and poor performance of a sulfate water. Hence, if you use the less C3A content in a cement, then that is called as a sulfate resisting cement. And the second factor is quality of concrete. A well designed placed compacted concrete which is dense and impermeable exhibits a higher resistance to sulfate attack. Similarly, concrete with a lower water cement ratio also demonstrate higher resistance to sulfate attack. So the properly designed concrete with a good water cement ratio and compaction and placing reduces the sulfate attack. Use of air entraining reagents admixtures also prevents the sulfate attack of a cement. And use of pozzolana. What is the pozzolana? Admixing a pozzolana converts the leachable calcium hydroxide into insoluble non-leachable cementitious products. This pozzolanic action is responsible for impermeability of a concrete. Secondly, the removal of calcium hydroxide reduces the susceptibility of a concrete attack by magnesium sulfates. Yes, when a calcium hydroxide is removed, then the magnesium sulfate will be less. Hence, the use of pozzolanic materials will reduce the sulfate attack. And in the curing method, the high pressure steam curing will prevent the attack of sulfate attack. High pressure steam curing improves the resistance of concrete by sulfate attack. The improvement is due to the change of C3AH6 into a less reactive phase and also the removal of or reduction of calcium hydroxide by the reaction of silica which invariably mixed when a high steam curing method is adopted. So the steam curing is also one of the method to prevent the sulfate attack. And use of high alumina cement. The cause of great resistance shown by high alumina cement to the action of sulfate attack is not fully understood. However, it is attributed in a part of absence of any pre-calcium hydroxide in the said cement, a contrast to the Portland cement. High alumina cement contains approximately 40% of alumina, a compound very susceptible to the sulfate attack when in normal Portland cement. But this percentage of alumina present in a high alumina cement behaves in a different way. The primary cause of resistance is attributed to the formation of protective films, which inhibits the penetration of sulfate ions into the interior. It should be remembered that high alumina cement may not show higher resistance to the sulfate attack at higher temperature. Only this high alumina cement will work out in a lower temperature. When higher temperature occurs, then the resistance of sulfate attack will not occur. Hence, using high alumina cement at a lower temperature can prevent the sulfate attack. So these are the some of the methods which can prevent the sulfate attack to the cement. So if the sulfate attack is prevented, then there will be a less cracks and the concrete will be more durable. This is a one chemical action of a cement. So we have remaining chloride attack and carbonation that we'll see in the next video. Thank you all of you.